Thank you everybody for coming out today. We'll be talking about data visualization, specifically going beyond graphics. If you've attended one of these workshops before, I've talked about sort of utilizing code and sort of development and things of that nature. Today's conversation is simply more or less just me showing some of the more extensions of what data visualizations are, specifically taking data visualizations from basic graphics to more interactive, more dynamic actual visualizations. There is a little bit of overlap between the first workshop and this presentation, but for the most part, it's actually a lot of new material in this regard. And we'll go to about about 5:15, and hopefully if there's any questions or anything like that, that'll sort of allow me some time to make sure I get the follow up with people as well. For the most part, I think everybody is muted on their end, so it would be best is if you have any questions or anything like that, please go into the Zoom chat and just let me know. I can stop and make sure I sort of answer questions throughout the presentation. But for the most part, I think as long as everyone can hear me okay, and we have everything being shared on my end here, we'll kind of start from here. I do record these as well, just so I can make them available afterwards, just as a heads up for, just in case anyone is wondering. We put these together and then we make these available through the ICS website. So let me get started here. Okay. All right. So like I mentioned, my name is Zack Patrick Dudas. I've been doing data visualizations now for about 10, 11 years at this point in time. So it's a lot of the things that I actually go through is actually a lot of the processes that we'll be talking about today is about sort of how I go about sort of extending sort of basic ideas of graphics and of making them more interactive in that regards and adding a little bit more of that dimensionality to them. I'd like to thank the Institute for CyberSciences. It's one of the groups I actually work for, but they are nice enough to also do some of the communications for these events so people sort of know these are occurring. Also, during my live versions of these talks, the Teaching and Learning and Technology group provides that space, so I'd like to thank them as well. Who am I? Basically, I'm a PhD graduate who specializes in data visualization, social media, data mining, and a little bit of cognitive psychology, but for the most part, data visualization and the information science department. I support the HUC, Institute for Life Sciences, the Institute for Cybersciences, and the Everly College of Sciences as well. The first thing I would like to get into is, I'll make note of this as well. At the bottom of the screen here, you'll see a couple links for a lot of the things that I'll be talking about today. I try to do my best in terms of, I do cover a lot of material today, so for the most part, I try to provide as many links as possible. So if there's any sort of follow-ups, feel free to take the slides, go through them, email me or ask questions in that regard. But I try to do my best in terms of providing links so that you can kind of follow up with some of these topics. One of the more popular questions I get in this domain is, I have this type of data, how do I visualize this type of data? And I actually stumbled upon very recently a tweet. I follow a bunch of people in terms of people who are interested in data visualizations and that type, and it's sort of a great resource in that regard. But somebody had mentioned that there is a couple websites that are sort of archiving these websites, putting these websites together. And I have them on the screen now, but I'd like to kind of show just a few of those off. And what they are is sort of a good ways of just, again, sort of saying, I have this type of information, how do I visualize this type of information? So one of the websites kind of goes into, I want to do a comparison, I want to show a relationship, and you kind of click on it and it will give you the types of visualizations that would be sort of applicable to that type of data set. And this even goes on past, it actually has some R graphs as well. I know typically a lot of people go from something like Excel to something like R or ggplot. Again, there's sort of a nice way of actually saying, here's some different ways to actually do some graphs in that regard as well. So again, a couple of nice little links for that. There's even actually one for weird types of graphs, or I consider them being more out of the box types of visualizations. Very kind of cool looking sort of visualizations or graphs in that regard. So again, you kind of look through these, kind of see if there's anything that maybe fits the type of information you're trying to sort of represent. And again, you can kind of check these out at your leisure. If you have any questions, please feel free to follow up with me as well. So I kind of just wanted to start off with that, just making people aware of that. Okay. And so the first thing I'd like to sort of talk about is why do we actually use visualizations? I have a quote here, basically kind of going into the idea that if people are interested in exact precision of information, why not just use tables? And a lot of times, if, obviously you want to sort of have some different ways of looking at this type of information. And one of the things I'll be looking at for the next couple slides here is a book by Stephen Pugh, who it's a wonderful resource. I'd highly recommend it. But for the most part, one of the things he sort of mentions is taking this information and sort of discovering patterns. So as an example, on the screen here, you can see that we have 2007 sales revenue for whatever company, domestic and international. And for the most part, if you would look at this type of information, you might say to yourself, you might see outliers, you might see specific trends or something to that effect. But for the most part, we might, from a human standpoint, it's very difficult to see these specific patterns. So the first thing you might do is take, graph these types of information out, and we see, oh, specific patterns are sort of forming from this information. The domestic has sort of a seesaw pattern, and the international sort of has a drop down in August somewhere. And so this is sort of the first sort of reasoning of why people actually utilize visualizations or graphs and to sort of highlight these specific types of patterns. Things like symmetry, things like something that's higher or lower, sort of comparison type situations, sort of looking at clustering or gaps or something to that effect. It basically kind of gives you some sort of way to sort of see information, specifically data points, in a way that allows you to compare, to understand, and sort of take away information as well. One of the things I'll make note of is that this actual presentation is a little bit more interactive, and I understand I'm not going to get a lot of feedback considering I'm the only one talking, but for the most part, I still want to have this included as well. So one of the first things, and you might want to think about, still in it's the same sort of conversation, is there's this idea called working memory, sort of your temporary memory in this regard. So what a little exercise you can actually try doing is, on the screen here, I have 12 letters, and what I would ask somebody to do is sort of look at these 12 letters, and after a few moments, I'm going to remove them, and you're going to try to remember them as best you can. And so I'll leave this up for a couple seconds. And again, we're trying to sort of memorize these letters and then come back to them. So again, I don't really have a good way of sort of interacting per se, but for the most part, you try to recall all those letters that were on the screen at that point. Now, if I take these same letters and just rearrange them, and again, sort of the same idea, try to remember them, and then take them away, more than likely, you're probably going to get more of that second sort of go around, even though they're the exact same letters. And the idea is the fact that we've made things more meaningful. There's this idea that people sort of have this memory for 7 plus or minus 2 things. So when you think about trying to remember 12 things, it becomes a little bit more difficult in that regards. But if we make things more meaningful, it becomes easier to remember longer sequences. So instead of just random letters, we see TV, FBI, JFK, YMCA. That's 4 things that we have to remember instead of 12 individual things. And what they call this, and basically the cognitive side of the conversation, is sort of the cognitive chunks. You're remembering chunks of information. So one of the other things that visualizations provide us is this idea of visual chunking, making things more memorable as well. So we can sort of remember general patterns from the data set. For the most part, if I would ask you to retrace the sort of what we saw, you might not remember the specific data points, but you remember maybe the saw point, saw graph that we saw before with domestic, that the domestic was larger than the international, or there was a dip in international at the August level as well. So again, visualizations help with understanding overall patterns, but also helping with memorization and sort of usability of those types of those specific data points. One of the things I also include through this talk is sort of these lessons as we kind of hit some various points throughout the conversation, because I do cover sort of a large sort of a gamut of sort of a lot of different topics in this conversation. So basically, I have these little lessons throughout to kind of just highlight some of the things we've kind of talked about. Basically, visualizations highlighting these patterns, and patterns allow us for better understanding at a higher level and then increased memorization as well. One of the first things you kind of have to consider when it comes to data visualizations as well is sort of how you're going to sort of set up your, sorry, set up sort of specifically how you're going to sort of set up the actual visualization in terms of, are you going to set up something more reader-driven or something more author-driven? So basically, the analogy I sort of created on the screen here is on the far left-hand side are these things called encyclopedias. For my younger audience, instead of Wikipedia, we used to use things called encyclopedias. And for the most part, these encyclopedias were set up in a way that was independent. For the most part, basically it was about topics, but for the most part, it was just information. And so and they were also set up alphabetically, so you could sort of find things very quickly and sort of work with them very quickly as well. And that would be something more reader-driven. It's basically allowing the individual, the reader, to find the information and explore as much as they would like to. The author-driven approach is more, I have a comic here, basically sort of author-driven. It's basically built on the idea that the author is telling the story. They're very linear in terms of their stories, there's heavy messaging, and there's little to no interactive in this regard. You're basically just telling the story. And so the middle part, the mid-ground between these, where the Venn diagram sort of intersects with one another, is this choose your own adventure idea. So there's an author sort of creating the story, but you can sort of choose paths and explore things as you would like to in that regard. Again, sort of specifically kind of stuck to the storyline, but for the most part, you have a little bit more freedom in that regard. And the reason I kind of bring this up is the fact that when you think about sort of how to design visualizations, you kind of have to think about how you want to actually approach these problems in terms of, do you want to be more author-driven or do you want to be more reader-driven? Reader-driven typically is something where you find in modeling. When you model information, you're not really putting a lot of character into that actual display. You're just basically trying to reproduce or replicate the actual system that you're trying to put together. And a lot of times those have no specific ordering to them, and you're basically allowing somebody to sort of interact, rotate, zoom, click on things, and sort of get actual information specifically from this actual visualization, this modeling approach. On the right-hand side, I have something that's more akin to an infographic. An infographic that's sort of very author-driven. You have a way of sort of setting up the messaging. You're sort of saying, here's the information and how you would like somebody to sort of follow through this type of information as well. And then in the middle, I have sort of just more of a sort of a general sort of reader, but also author-driven approach where you have some sort of control in terms of the visualization. You choose coloring, you sort of choose what types of fonts you're going to be using, how things are going to be laid out. But for the most part, you allow people to interact and sort of engage in this as much as possible at their leisure as well. So first off, it's just trying to figure out how to specifically drive the message. Are you going to how you're specifically trying to set it up in terms of your sort of storytelling, if you will. So a couple infographics, just a couple examples of these. The Napoleon disastrous Russian campaign of 1812 is considered to be actually one of the premier sort of graphics that are out there specifically. It's kind of one of the better ones that you're going to find in this regard because of the fact that it sort of showcases Napoleon's march to Moscow and back to France. And specifically the size of their army, and as they sort of traverse into Moscow and come back to France in that regard. And you just kind of see how the army size sort of dwindles, obviously, as it gets closer to Moscow and as it returns as well. A lot of information, but it's something where you're not interacting with it, but it's considered one of the best in terms of presenting information and letting somebody sort of look at and sort of observe and sort of do the storytelling that way. There's actually there's a lot of push for this type of sort of approach nowadays in terms of the domain I'm in, specifically like data visualization. One of my favorite examples of this is actually a recently published book called Dear Data, where two sort of artists, if you will, data visualization experts, kind of go back and forth once a week, sending postcards to one another. And what they do is actually take data from their everyday life and try to figure out creative ways of actually highlighting specific patterns and things of that nature. I highly recommend it. Not a lot of sort of specifically text to the actual book, but for the most part, it just sort of has these pictures that allows you to kind of sort of look at sort of different ways to take data and create new patterns out of it. kind of breaking away from the sort of the norms that we're sort of, we're typically kind of showed in terms of data visualization, the pie charts, the scatter plots, the things of that nature. So very creative in that regards. In terms of modeling, one of the ones I've seen before is called Apollo, looking at document modeling. And what this is built out of CMEO, it's Carnegie Mellon, where they allow people to sort of search articles and then find articles that are of sort of like type in terms of the content itself. Couple things in terms of visualization qualities to them, some coloring, and some network sort of qualities to them. But for the most part, it's meant for you just to explore that space. This is something I've done before in the past as well. This was something, a project we put together I've worked on before called Dynamic Tweet Network Analyzer, where we allow people to sort of collect tweets, look at them on a map, sort of look at things in real time. But for the most part, the idea was for somebody to sort of explore this space. Not a lot of sort of gimmicks in terms of the visualization per se, but for the most part, to allow somebody to sort of explore that space, download this type of information and sort of utilize it for projects. In terms of basic sort of more visualization specific, so sort of that overlap. And on the bottom portion of the screen, I'm not going to go into too much detail with a lot of these, but for the most part, you can kind of see looking at meteorites that have hit somewhere across the world and sort of seeing what the specific patterns. You're seeing a lot more color involved with this, a lot more sort of dimensionality in terms of the information. Something you can still interact with, but for the most part, it's also telling a story as well. Sports participation, again, sort of another way of sort of taking information, making it interactive, making it sort of more engrossing, and bringing somebody into that conversation in other ways. And again, interactive, allowing you to sort of go through, click on things, explore, do deeper dives in this regard. But again, sort of a mixture between this idea of reader versus author driven in that regard. So for the most part, the second lesson is basically kind of coming away with the idea that we have to think about how, when we're developing some sort of graphic or visualization, how we're specifically tailoring that message. Are we sort of trying to tell a specific story? Are we trying to have a specific message? Or are we looking for allowing somebody to have that exploration? It is very possible to do both, but for the most part, it's better to kind of sort of choose one of those sides to sort of tailor that specific message to that specific audience, if you will. The next major sort of conversation to have about sort of visualizations and graphics is sort of the two various ways you can sort of showcase information and have it sort of tell the pattern, tell the story based on the patterns themselves. And the two ways that I'll be talking about this is both spatially and something called retinal variables. So things like color, shape, size in that regards. So in terms of spatial, this is basically sort of how things are laid out, the layout of the specific visualization or graphic. I come back to this slide because a lot of this has sort of tells that same story. Again, sort of looking at patterns and how we want to actually physically lay out the actual information on a piece of paper or some sort of visualization. Again, so I'll kind of click through these. One of my favorites in this regard, in terms of it's not the most appealing thing to look at, but one that I think is really kind of cool in terms of its spatial layout, is looking at sort of these train scheduling. So instead of giving you specific times of when, going from Paris down to Dijon, it actually sort of lays this out in a sort of a unique way. So you can kind of see as time progresses. So if I'm interested in trying to catch a train at a certain time, I can sort of connect the dots between Paris and Dijon. It not only tells me sort of the intersections between all these different railroad stations, but it also kind of gives me an idea of how long things are going to take, specifically based on the length of the line or how actual gradual or sort of sharp the line is as well. Kind of gives you that type of information if it's a direct route or not. So spatially, it's kind of interesting in terms of taking sort of these table sort of displays and making it something that's more sort of unique and sort of understanding spatial relationships. Again, not visually the best sort of looking design, but for the most part, I think it does a good job in terms of that spatial relationship. Considered to be one of the worst in terms of these spatial relationships. And there's a name I'll be bringing up a couple times through this, and basically Edward Tufte. His books, he does a lot of these types of talks in terms of design qualities of visualizations and graphics. Highly recommend checking him out in terms of if you're sort of interested in this conversation. He has a 4 books out right now, I think it is, and all are worthwhile in terms of sort of going into better types of conversations about design of graphics in this regard. So don't be surprised if the name's brought up again. So the one the graphic I have on the right-hand side here, in terms of being a bad spatial sort of relationship, looks at the age structure of college enrollment. And as you can see at the top here, we have one graph that is under 25, and the bottom graph is 25 and over. Initially, this obviously tells you it's actually sort of a poor representation of this information because it's not intuitive. The fact that the under 25 is above the one that says 25 and over doesn't necessarily sort of, it's not sort of the best way to sort of lay out something like this. You'd sort of assume they were reversed in that regard. Also, you kind of see sort of this faux 3D effect that's kind of going on here, where it kind of goes back to a general sort of place within the background, but can be sort of misleading in terms of specifically kind of, is this actual data or is this sort of just that 3D effect that's going on? And finally, you sort of expect to be able to sort of directly compare these types of information. It's kind of hard to, and as you can kind of see, this goes up to 34 here for this bottom plot versus 66 for the top plot here. So again, it kind of looks like the same distribution, but the numbers are very misleading in this regard. So this would be sort of a good example of bad spatial relationships. Another one I always bring up when I do these types of conversations is the Challenger explosion that happened in 1986. Specifically, the way this information. So if you actually don't recall what happened during this tragic event, well, there was a damage specifically to something called the O-ring. So on the left-hand side, you see basically a bunch of different testing phases throughout the actual process of putting the rocket together. And so as we go through here, we have rocket 1 and rocket 2, and you kind of go down through the line here for the different sort of testing throughout this process. And we see a number specifically tied to temperature. And if you see any kind of blemishes or markings, that means there was some sort of issue. And for the most part, I'll move this over. And for the most part, on the right-hand side, you see that we have sort of this same type of information. So the left-hand side was what they used to sort of capture this type of information. And it's what they use for their sort of knowledge, if you will, in terms of making decisions if they should have the launch or not. Not a lot of patterns in terms of what's going on the left-hand side. But if we take this same information and replot it just on a simple sort of XY coordinate, where the Y coordinate is number of the damage index. So the larger the value, the more damage that occurred. And on the X-axis, we put the temperature. We can kind of see very quickly that there's sort of a general pattern that as the temperature decreases, we have sort of a lot more issues in terms of damaging that's going on to these O-rings. And it just so happens on the date of the actual launch, even though it was in Florida, it was a very cold day, and it was about 26 to 29 degrees on that given day. And unfortunately, what happened was there was a damage to the O-ring, and the Challenger itself exploded during sort of that tragic event. So even just sort of taking the same type of information and making it more usable, sort of taking advantage of sort of spatial relationships, can be sort of a good first step in terms of creating more usable types of graphics in this regard. Back over. Okay. This slide basically kind of goes into, and I know you can maybe miss a little bit of the top there, but for the most part, sort of a nice little overview of different ways to take information and sort of apply it to specific data sets. So if we're looking at quantitative values, numeric data obviously, or something that has more of an order to it, ordinal information, or nominal in terms of labeling, label type information, how we can actually apply different sort of techniques to sort of heighten and sort of compare information, if you will. Specifically, positioning is predominantly the best way to sort of handle any type of information in this regards. But things like, different color saturations or different coloring hues themselves can sort of be a good way to handle ordinal types of information. And you can kind of go through sort of the list here, and I bring this up again specifically for the retinal variables we're talking about here in a moment, but sort of a nice overview. This type of research has been going on for decades at this point in terms of I have a relationship that I'm trying to showcase, which way is the best way to sort of show those differences, if you will. And so this is sort of a nice overview of that information. One of the things that we will kind of see throughout this conversation as well is I kind of mentioned some optical illusions. Not per se that they are tied directly to anything specific in terms of these talking points, but just kind of things to consider whenever you're thinking about sort of design processes or designing of graphics, if you will. On the left-hand side, this is called the vertical horizontal illusion. And basically on the left-hand side, predominantly most people will actually see this vertical line being larger than the horizontal line at the bottom here. And on the right-hand side, we sort of show these measurements so that you can prove that, yes, they are actually the same size, which they are. But what you sort of see through this is this idea that thinking about this in terms of if you're setting up a graph of some sort and using sort of a common line between two graphics or something like that could actually mislead people in regards to sort of just these spatial relationships and saying sort of values are larger versus being smaller because of this simple type of illusion. And again, these illusions are going to be kind of mixed in throughout this conversation. Just kind of interesting to sort of see how sometimes, even though we might try to specifically approach the problem at an optimal way, sometimes these things, these illusions that sort of occur during these processes. And the interesting thing about this horizontal vertical sort of illusion is that it actually can be affected by things like development. So a child is more likely to be affected by this than a young adult or an adult themselves. Gender differences, they've actually seen these in cross-cultural differences as well. So again, sort of just something sort of interesting to kind of mention. The other thing, another one I kind of always like to mention as well, is that when you're thinking about, let's say, plotting multiple lines on a given graph, there could be something that could sort of run into something called the Leaning Tower illusion. We have here two images of the Leaning Tower of Pisa, and actually these two images are the exact same picture. They're just copied and pasted and put beside one another. But for the most part, a lot of people will see the right-hand figure to be lean a little bit more than the left-hand figure, and that just basically because of the fact that we're sort of changing the sort of the orientation, or excuse me, the direction of this actual right-hand picture, so the angle, if you will, based on the other image as well. So if I actually separate these apart, you can actually see a little bit better that yes, these are the exact same image. Just a little bit sort of when you put them close together, sometimes you might have sort of this illusionary effect sort of come into play, where you're using one of the lines or one of the sort of images as sort of your baseline in terms of the other image, and sort of this illusion might occur in that regard. This can also occur if you ever are going into some sort of 3D graphical sort of display. People sort of look at things in terms of based on sort of prior information. So if you look at this graph here, these two lines are the exact same height and width, but again, sort of looks at, it might mess with you in terms of one looking larger than the other. All it has to do with the fact is that one is in the foreground and one is in the background, and we sort of tie in that they sort of are different sizes in this regard. More specific to 3D graphics, so not per se tied too much to this conversation, but again, something I thought was kind of enjoyable in that regard. So in terms of some graphics or visualizations, I'll kind of make mention of a few that sort of doesn't work as well in terms of the spatial relationship. I'm typically, sometimes I'll get requests to make word clouds, sort of these word clouds that you kind of see on the screen here. Typically, I kind of shy away from these specifically because they kind of don't have they sort of mislead the spatial component. So what I mean by that is, even though they're visually interesting to look at, and typically like the larger the word, the more times it occurs within a given document. The spatial relationship is sort of removed from the conversation. So the reason why the word information is above Wikipedia doesn't necessarily mean anything versus where the word, obviously we also have an issue in terms of one being lowercase, one being uppercase, but for the most part, there's where the words are sort of formatted and put on the screen per se, sort of doesn't matter. So the spatial component is sort of removed pretty much entirely in terms of this conversation. So there's sometimes some issues with things like word clouds in that regard. So even though they're kind of interesting and cool to look at, maybe not the best sort of approach to sort of taking this information. Another one that sort of falls sort of flat in that regard is looking at things like pie charts. Pie charts people have a poor understanding of angular distances. And so when you use pie charts, if you start putting more than 1 or 2 or 3 sort of cuts in your pie, if you will, you become sort of, it actually starts sort of removing some of its usability. Specifically, like some of the, obviously the one on the right-hand side is very egregious in this, and the fact that it uses multiple different colors multiple times. So basically that becomes a lot less useful, obviously, or when you're not representing 100%. So the question being, what are your 3 most favorite types of pie? Obviously that doesn't, these numbers don't add up to 100%. So we run into sort of this issue in terms of representing it in a pie form, if you will. Okay. The best kind of pie in terms of a pie chart is sort of humorously is basically when you're only comparing 2 different types of sort of variables, if you will, or 2 different distributions. So pie I have eaten, pie I have not eaten, sort of is the best sort of approach to utilizing pie charts. I do hope, I understand that it's getting a little bit closer to dinner time here, so I know this is going to sort of, we're going to be talking about food for a moment here, but for the most part, things like pie charts, which we've seen before, and donut charts are actually sort of poor representations of spatial relationships. If you want to take sort of percentages, you actually want to use something called a waffle chart, and that's what's pictured here on the right-hand side, where you have 100 squares, and then you sort of fill in the squares. So comparing different distributions become a little bit easier for somebody visually to sort of see those differences a lot clearer in that regard, versus something like the pie chart or the donut charts listed here as well. So again, if you have data that sort of works that pie chart format or donut chart format, consider using a waffle chart instead. So my lesson for this is basically using spatial relationships to take it to your advantage, so to maximize that as much as possible. Be mindful of side-to-side spatial relationships because they can sort of be effective, a little bit per se, based on sort of the orientations and things of that nature, and the angles between the 2 lines as well. And again, waffle charts are better than donut charts, which are better than pie charts. Next, we go into the idea of retinal variables, or visual sort of, they are called visual variables as well. And what this means basically, and I come back to this chart because they're included as well, this is where we're talking about changing things like color or shape or size or things of that nature. So we can sort of use spatial relationship for one dimension and then use these different shapes and colors and sizes as another dimension to sort of showcase information. And again, I kind of just wanted to highlight these 2 graphics again, but kind of show where these actually lie on these different scalings, if you will. There's a topic, if you're sort of going a little bit deeper into this conversation, when you have to think about what's the best way to sort of showcase, let's say you have 2 variables that we're trying to sort of plot out, and making sure we have the sort of maximum distance, if you will, or we call this the just noticeable difference between 2 different things. You would not want to just use 2 colors that are sort of like, a blue and a greenish blue, because there's not a lot of distance between those given colors, if you will. So it's harder to sort of disseminate between one of those colors and the other ones as well. So a lot of times, and again, I won't go into too much detail about all this sort of thing, but there's sort of this concept called psychophysics, where you kind of think about what is the just amount of information that needs to be separated between these 2 variables. Using a triangle versus a circle is a larger distance between using a hexagon and a circle. Again, cognitive-wise, you're just sort of trying to maximize that distance between them, just so when you're displaying these two variables, it becomes easier for somebody to say, oh, there's that one part of the data, and there's the other part as well. Some example mappings in this regard, things like ordinal and nominal scaling and quantitative mapping as well. You can change things like the glyphs, so the shapes of the actual objects, sizing, variations, orientations. Also coloring is sort of going to be sort of a major conversation piece in this regard too. A couple more lists in this for this is going through various links, positioning obviously being one of the more precise ones, width, size, intensity, blur, things of that nature, sort of being tied into this. With this dimension, things can become a little bit more interesting in terms of the idea of graphical integrity. So on the right-hand side, and the example that this is sort of a good example of how to sort of take advantage of some of these types of ways of actually sort of encoding information. So what we have here is the shrinking family doctor in California. So we have percentages that were being represented by these characters, these doctors. But the issue with this is the fact that it's actually, even though we're sort of using one dimension of information, so the percentages going from 27 to 16 to 12, we're using both. You're basically using area. So we're changing both the X and Y of the given doctor. So it's actually sort of heightening these differences. And even though I talked about sort of wanting to maximize this, this would actually be sort of something where you have to think about misleading information. So instead of it being sort of a linear scale, we're now sort of making it sort of X squared, if you will, or area type of information. So you're sort of exaggerating the differences between 27 and 16 and 16 to 12 at that point. That's why they look dramatically different in terms of their sizing, but for the most part, they're just sort of they should be linearly different in this regard. So even though you want to maximize this distance as much as possible, you don't want to do it to a point where you sort of are misleading people in some way, shape, or form. Another thing to consider, and another illusion I sort of bring up here, is that what happens a lot of times is if you have multiple different sort of objects on the screen, specifically circles in this case, we are we can actually visually become biased towards certain situations where, in this case, we have larger circles around an orange circle and then smaller circles around the other orange circle. Even though the two orange circles look different from one another, they're actually the same exact size. And for the most part, a lot of things in terms of context come into play for these types of conversations. So when we're thinking about using different sizes for different objects, specifically, we want to create a bunch of circles, but we want to use different sizes. Be cautious of the fact that we sort of use that context around a given object to sort of judge the size of the other object as well. So in this case, even though they don't look similar to one another, they actually are the same size. We're just sort of using different contexts based on the sizes of these circles. In terms of processing, in terms of people's sort of understanding, we can kind of look at this in terms of, there's this idea of bottom-up processing, which basically means we take the information at its sort of root level and sort of just take what we have sort of provided to us. The top-down processing, sort of when people look at objects or looks at visualizations or graphs or anything in general, we provide some sort of context to that situation. On the right-hand side, you might be able to read, for the most part, I'm assuming that most people can read these words going down that list, seeing red, spot, fish, index. The reason why you can read this without sort of having all these blotched out areas is the fact that you can provide some sort of context to this situation. And so that context becomes sort of crucial in a lot of these conversations, as we saw before in this type of illusion, if you will. This is something we use for top-down processing. We know that there's no word that's reb, so we know it's supposed to be the word red or sort or something to that effect. We know that's the only word that makes sense in this situation is something like spot. So we apply sort of background or context to these situations. And this is true with visualizations and graphics as well. I won't go through sort of the demo, but I'd highly recommend one of the provide this link where it talks about this idea of pre-attentive processing. Basically, it talks about a lot more of the visual variables, the different ways of angle or shape or size and stuff like that. And this is sort of a great resource for that. In terms of this context, one of the things that we've found out through some of these sort of conversations is this idea, that basically that even things such as language can sort of affect the way that we actually see or sort of approach even something like coloring. On the right-hand side, the idea of the researcher or the experiment was they would give participants these 3 different colors, and they would ask the participants to find the one that's different. So this lighter blue color on the right-hand side. And for the most part, when they tried to do this between 2 different groups in terms of one that was English-speaking versus Russian, we saw that they actually saw that the Russian language, because of the fact that it does not necessarily have a specific word for the color blue, it has 2 words, basically light blue and dark blue. They were better at sort of this specific type of task. Meaning basically language could be sort of that context that I mentioned before. So that top-down processing can even for something like color, can be affected by vocabulary or language specifically. So things like, and some of the other examples you can kind of think about, somebody who's an expert versus a novice in certain fields, or a painter in this case would be probably better at this experiment versus people that are not painters in this regards, because they have a better understanding, a better lexicon, if you will, of different types of blues or different, specifically blues in this sort of experiment, but this actually affects the way we can actually differentiate color as well. And so language actually sort of is tied to our, even just something as simple as our ability to identify color is actually tied to our language as well. And actually included sort of a quote about this in terms of our words literally shaping the way we categorize things in the world around us, kind of an idea. What I have next is basically another sort of idea in terms of language being affected by, and coloring being affected by language. This is called the Stroop Effect. So what I'm going to actually do is that you're going to see on the screen here, and again, I understand I'm not going to get sort of feedback in this regard, but you're going to see a word, and you're just going to sort of, to yourself, sort of say, what color am I seeing? So we go through the first one, we would say black, and then I would click through these. And I'll kind of go through these semi-quickly. And for the most part, if you would try to go through something like that, and maybe it became a little bit more difficult for you, specifically in cases where there was a disconnect. So the word would come on the screen, you would think red, and then you would see the blue coloring. And so when you sort of, this specifically is called the Stroop Effect, excuse me, and how it sort of affects the way you sort of tie the color specifically to the terminology or the lexicon itself. So kind of an interesting way of doing that. We can actually take advantage of something like this in terms of visualizations or graphics. If you ever have sort of a situation where you're trying to create a visualization or a graphic and you would like to sort of point people to a specific location. So you want to use the data to sort of migrate someone's eye to a specific part, which is what you think is the most interesting part. A way to actually do this is to utilize warm and cool colors. If you ever happened to, when I was younger, we used to play like Marco Polo. So you get warmer as you get closer to something and cooler as you get farther away from it. So this actually, because of sort of this interaction, actually works well in terms of visualizations as well. So if you have something that's very interesting on the top right-hand corner of the screen, you use warmer colors as you got to it. And so people would actually draw their attention specifically to that. In terms of context also, you know, obviously if you're creating something specifically, let's say it's weather specific driven, and you have temperatures, obviously using warmer colors for something that's warmer in terms of temperature, and cooler colors for temperatures that are colder in that regard. So you want to make sure you maximize those sort of the understanding of context within those given situations. So for this, lesson 4 kind of goes into encoding can vary based on the task and the measurement scales that we're looking at, we saw before. There is a very strong relationship between language and understanding and color. So making sure that you sort of maximize things like top-down processing. Understanding context is very crucial in terms of design. Understand the audience and sort of play to that specific audience as well. Sorry. I'm not sure what happened there. Okay. Okay. Sorry. Maybe somebody annotated on the screen. Sorry. So moving on. So the next topic I'll be going into is this idea of color. So I've kind of hit a lot in terms of color at this point, but the idea of color in terms of how much information is actually out there would be way too much for a conversation, just something simple as this conversation today. When I was looking at PhD programs, I actually looked at the Rochester Institute of Technology, who has a dedicated PhD program specifically in color science. So you spend 5 years learning about color and specific projects sort of relying around it. So the idea of color can be a very sort of long tenured idea. So we'll hit a couple major topics, but for the most part, I'm not going to hit everything today. So just sort of a heads up on that. First, the idea that there is a color spectrum of some sort. Specifically, there's the infrared versus ultraviolet, and sort of the color spectrum that we actually see sort of falls between those two spectrums specifically. When we think about color, it has a subtractive quality to it. So when white light hits an object, whatever light that sort of bounces off that given object is the light we see in terms of the color we see as well. And typically what we have when we have these conversations, specifically somebody new to sort of graphics or visualizations, we typically talk about things like RGB, so red, green, and blue, and using that as sort of our palette, if you will, for creating colors and sort of variations. We use color a lot of times to, color is obviously a predominant way to sort of highlight specific objects given a given display. So on the left-hand side, if I were to ask you to find all the cherries in this given image, you might be able to do it, but it might have some difficulties versus something that's actually colorized. So we can very easily to see sort of the red objects in with the green sort of leaves in the background as well. But saying that, one thing to also mention as you're thinking about these color palettes is the fact that 8% of males are actually red-green colorblind. So a pretty large sort of percentage of our population might be colorblind. So it's something, again, to sort of consider as well. So here's a couple examples of color palettes that you might, if you are colorblind to some degree, would have some difficulties looking at. And so I kind of just created a grayscale for this, so you kind of simulate, if you will, not exactly, but simulate sort of what somebody who was colorblind would see versus what's actually there. Again, not one-to-one, but it kind of gives you that idea. So I talked about this idea of RGB, the red, green, and the blue, and how this is sort of our typical way of taking, color and sort of understanding color. There is sort of a couple issues with RGB, and my hope is by the end of this conversation, you'll kind of rethink the way we think about in terms of color when you're sort of selecting specific patterns. In the figure on the left-hand side, if you were asked to go from the left-hand color green all the way to the right-hand blue evenly throughout this RGB sort of color palette, you would see that the blue works pretty well, but the green has some variation. There's some muddled colors between one another. And that's because the RGB space, the red, green, blue space, was created sort of more specifically, so it's tied to more just sort of the color palette itself and not human perception, if you will. Another way of actually looking at this is something called CIE Lab, or sort of their approach in terms of taking actual human perception into this conversation. So on the right-hand side, and I have a link to sort of some shortcuts to this conversation, so you don't have to really focus too much on this, but for the most part, it's sort of if you have the option, if you're in ggplots or Excel or any kind of Adobe products, try to sort of navigate your way to using the CIE lab versus the RGB sort of display. But for the most part, this CIE lab, it looks at sort of using more human understanding, human sort of understanding of coloring and sort of their actual sort of gamut of colors, if you will. And so it ties it directly more to how people perceive color versus the actual sort of more static approach that RGB is. Another approach is to use something called the hue, saturation, lightness, or hue, saturation, and value approach. So on the left, you kind of see, so you take one color or one hue and change saturation levels or change lightness. Saturation basically means if you are completely saturated, you're going to see, if it's red, it's going to be a very deep red, versus saturation going to being all the way white, if you will. So from that red to that completely being white, versus lightness, which goes from the color basically to black, if you will. I list on here a link, and I actually listed again as well. A great resource for kind of simplifying this conversation is to use something called Color Brewer. And actually, when am I bringing it up? Color Brewer, actually it was developed here at Penn State at the geography department. Cynthia Brewer was sort of one of the main developers of this, hence its name, but does a great job of sort of helping people sort of design color palettes specifically for things like black and white printing or somebody who might be colorblind to that specific audience. And so for the most part, you can kind of go through and say, oh, I have X number of variables. I want to see how they look, having divergent colors. So I'll say sequential, and I'll say having 6 variations of color, and it'll let you sort of choose basically, it'll give you sort of the hexadecimal form of each of these, or you can choose the RGB one as well if you need that. But for the most part, it gives you sort of an easy way to sort of have these sort of color palettes that are already chosen for us. And a lot of times, again, ggplot or R and Adobe will have these built in. So you have to look specifically for something called Color Brewer in that regard. So again, a great resource, a lot simpler than me going and talking about sort of these variations, the HSL and the Scilab and things of that nature. So yeah, it's basically a lot easier for just to kind of use that resource instead. Another thing to mention is when it comes to color palettes, typically a lot of people will sort of gravitate to this idea of using this rainbow color map. Reasoning being the fact that if I use a bunch of different colors, different hues, and I talked about this sort of separation between variable, distances as well, these differences and stuff like that, when it makes sense to just use all the colors basically, and so you get these rainbow color approaches. Not always the best. There's actually been a lot of different publications on sort of using the rainbow color map and how it actually is a sort of a poor representation of variation between colors. And here's an example, and actually I'll jump to the black and white version of this. So if I take this same image and just change it to black and white, we see that even though we might have variation in hues, if we don't change things like that saturation level or don't think about it, or the lightness variable in that regard, you end up having a bunch of sort of colors that just mimic one another. And so different hues doesn't necessarily mean different interpretation of that color as well. So again, Color Brewer, great resource in this conversation. Instead of trying to use that rainbow color pattern, color mapping, think about using maybe one single color and varying that saturation level, or choosing 1 or 2 colors, but for the most part, you want to think about maximizing that distance, but also thinking about taking it and printing it off in black and white just to see how it looks and showcases that variation. Again, wanted to include this one more time, a great resource in this regards. So one of the things I also wanted to showcase in terms of, we saw this before when it came to sizes. One other thing to consider is the fact that when it comes to context, colors can be affected by sort of the context that is around it as well. So again, one of these optical illusions, if you will. So in this case, if you would look at this sort of spectrum, this grayscale, if you will, you would assume that what's going on here is that I had two different squares with two different colors. And when in actuality, if you kind of put them side by side, we see that they're actually the same exact color. And this is true in terms of not only a grayscale, but also any kind of scaling as well. So you have to think about when you're sort of having multiple colors involved or the variations of a color, how they sort of react to one another in terms of its context around it. I actually have an example as well. So I put this together. So let me zoom in a bit. So the blue plot here has these data points that go onto the graph, and then I'll move this down for a second. And you can see sort of at that same sort of bottom position there, they look like basically the same color because they are the same color, but when we put them within other contexts as well, so the white up to the darker blue color, it almost looks like I'm varying the color as well, which is not the case. All I'm doing is just moving them. And so what you want to think about as well is as you're designing these types of plots and you're using sort of color variation, trying to sort of making sure that one of the colors is sort of not sort of interfering with the other colors as well. So just keep being mindful of that as well. And this is actually tied to the checkered shadow illusion. So on here, I actually move that over a little bit. If you were to be asked if the A and B are the same color, for the most part, you'd probably assume most people would sort of assume that no, they're not the same color. I copied and pasted this just to make it a little bit easier to compare. Can't overlay it directly, but for the most part, they actually are the same exact color. And it's one of those situations where, again, we're context. So being surrounded by the darker squares versus the lighter square can actually sort of affect the way we judge that specific color. Okay. I included also a TED Talk, one of my favorite ones in terms of, I've taught this in terms of classes before, so I wanted to include it. Obviously, I'm not going to watch it now, but I just wanted to include it. It goes into sort of Neil, who's the speaker here, talks about sort of he's completely colorblind and how he uses sound to sort of heighten his ability to see color. As we talked about before, coloring being sort of a wavelength, you can sort of tie it to specific pitches as well. Which is what he did. So we're not going to, again, I'm not going to showcase this now, obviously, but I highly recommend checking out just kind of a cool conversation about how to sort of think about interpretation of coloring via using sound versus actual visual cues, if you will. Another thing I might take advantage of is something you sometimes might see something called the opacity levels or the alpha levels. Basically, it's a good way of sort of taking, in this case, we have two different colors overlapping the two and sort of seeing where they overlap between them. So opacity might be another way to sort of heighten our ability to kind of see specifically any general kind of patterns. In terms of on the right last thing I'll kind of mention, one more thing after this, but the one last sort of link I'll have sort of included with this is this is kind of a cool project called Adobe Color. If I go to this website, it's really kind of a neat way to actually choose color palettes. So if you're ever interested in sort of being a little bit more creative in terms of I need two different colors and I want to sort of create a color palette specifically for that, this helps in terms of saying, okay, I need complementary colors, so I can sort of take this and sort of move it around the wheel, and it'll help me figure out sort of what colors sort of work better for one another. So again, just kind of a nice resource in that regards. And sort of finally, in terms of the color conversation, is when you're thinking about, the retinal variables we talked about before. So we talked about different shapes or different, using a blurred effect or something to that effect. The best thing you can do in terms of having multiple variables, so male, female, or sort of different types of variables on a given graph, be redundant. So as you kind of move from left to right, we see that as we improve our distance between those objects, so a circle and a square versus a circle and an X, which look a lot different from one another, if we add color to that conversation as well and make things redundant, we can see that it's a lot easier to sort of see where parts of the data starts and one of the other ones starts as well. So it makes it a little easier visually to see this. So trying to increase that redundancy is always a positive as well. So my takeaway for this is basically color effects can affect our ability to judge other colors as well. So think about that context, use color Brewer. And if you're going to choose between color palettes, use HSL, so the hue, saturation, and lightness over RGB, and then the CIE lab over the other ones as well. So make sure you kind of try to select that as much as possible. The next thing, and sort of in this conversation, so we talked about using spatial relationships, we talked about retinal shape, size, and color, and things of that nature. Another thing to think about is, and this ties a lot to specifically the reader versus author-driven approaches, is should our visualization or graphic be stylized, or should it be minimalistic? And this is where Tufty comes into play in terms of this conversation. He is sort of the premier in terms of minimalistic design. He has sort of this mantra of maximizing data ink ratios and things of that nature, or eliminating chart junk. So I have a couple of slides that kind of highlight what he's talking about this. So the original graphic is on the left-hand side here, but for the most part, what we're trying to sort of maximize is these distributions. So this is sort of a reimagining of the same graphic, remove some of this information around it to minimize the amount that's going on here, so it makes it easier to make this comparison. Coming back to the chart that I mentioned before, where we had the train schedules, if you will. Another thing you can also do is clean this up a bit and sort of maximize the contrast between the lines and the background, so that grid, if you will. Also, one of the things he talks about is sort of this idea of 1 + 1 = 3. The best example is actually this one here, where you see the dark blue line, the dark black line and the dark blue line, and making sure that when you have sort of this white space between them, people sort of actually sort of assume that there's sort of a third color there. So that's where this 1 + 1 = 3 approach. So making sure you kind of minimize sort of these darker outlines in this regard. So here's an example where the bottom display here, is a better representation of this information, because you're basically minimizing the 1 + 1 effect, if you will. So these darker outlines sort of highlight the white space versus what we're actually trying to showcase in our given graphic here. So again, sort of maximizing this data ink ratio, if you will. And in terms of the optical illusion that I mentioned before, here's sort of a good example of that as well, where we have all these squares on the screen and the sort of the white space between them. What might happen as well is that you might see these darker little patches between each of these squares as well. So this is that 1 + 1 = 3 effect, sort of heightened, if you will. So this is sort of where that sort of third color comes into play. Or if you sort of, when you're sort of playing around with this white space as well, this idea of Gestalt sort of approach, in terms of we're seeing specific objects based on these. In this case, instead of most people, when they see this object, they're not going to see three, I'll just say sort of Pac-Man, if you will, or Pac-Man sort of they're going to actually see a triangle in this regard. So we sort of look at this white space and sort of judge and sort of create that object. Again, sort of this optical illusion. So what the idea is basically is trying to minimizing these displays to a point where just the data is being shown, to heighten the, sort of that sort of level of, and minimize sort of that added level of like that 1 + 3 effect, 1 + 1 = 3 effect. Now, that being said, when we're thinking about sort of creating visualizations, there's also the idea of stylized sort of approaches as well. Obviously, if we're talking about this data ink ratio, 1 + 1 = 3, these are not the best. I have a lot of extra, artistic sort of approaches to them. But one of the things to also consider is the fact that what some of the research has seen in this regard is the fact that when you stylize things a little bit more, people are more likely to interact with this visualization. So spend more time looking at it, explore that space specifically. Also, when you sort of increase the stylization, if you will, you're more likely to actually also help in terms of memorization. So people are going to remember these displays versus something that's more simplistic. So it's sort of a trade-off between the two. In my lesson, I kind of go into a little bit more what scenario is best for both of these occasions. So I'll come back to that in a second. Another thing to think about in terms of sort of this dimensionality or sort of the stylized approach as well is typically, obviously a lot of times we're creating two-dimensional graphics, obviously because we're using a monitor or a piece of paper or an article or some sort of poster or something like that. Another thing you can also think about is the fact that we can sort of take advantage of, we can actually sort of make this pseudo 3D effect, this depth perception approach. So on the right-hand side, we see that there's sort of a linear perspective, as they call it. So basically something that objects are going to a specific location on this given picture here, using things like relative size to sort of, so basically things in the foreground are larger than things in the background, obscuring. So objects in the foreground obscure objects in the background. And we can sort of create this sort of depth perception, 3D sort of effect as well. I mention this because it's one of those situations where you can actually apply these to, these are all two-dimensional plots, but you give it a little bit of a 3D effect to it, sort of add a little bit of depth perception to it, and you can actually use it as another sort of redundancy in terms of these graphics. So not only is color sort of one variable in this map over here, but we also use this 3D effect as well. So again, it's basically using something, a texture gradient to sort of do this pseudo effect. So another way to actually sort of add a little stylization and sort of heighten, if you will, that third dimension. So license sort of walking away from this is to minimize the amount of ink being displayed, the data ink ratio. If you don't need it, remove it. Understanding when to use simplified graphs versus stylized graphs. Typically, I'll recommend that if you're using something for a paper or for a presentation or something like that, you want to simplify things as much as possible. But if you want to, if you're using a graphic specifically for a poster, typically you want to go more stylized, specifically because that's going to draw attention to that given graph and allow you to sort of engage somebody in that conversation. And using depth as sort of a way to create the redundancy as well. The last thing I have for this is basically sort of talking about different dimensions in terms of dynamic visualization, something that's more of an animation type situation. When we think about sort of creating more dynamic visualizations, there's sort of a typical mantra people will use by Ben Schneiderman that looks at sort of this, provides sort of the overview of the information first, allows somebody to zoom, filter, and then details on demand. Details on demand is this idea that if I mouse over something, it'll give me the actual values or allow me to sort of dive deeper into this visualization, if you will. So this is sort of the beginning states in terms of creating more interactive visualizations. In terms of interactivity, we can think about this in terms of the lowest level being, just allowing somebody to manipulate the information, select objects in that regard, or allowing people to explore, navigate, creating more things like mental maps. So basically taking that space and sort of allowing them to explore it and memorizing it and sort of making sure we sort of attach a specific type of mental map specifically to it. Or another level is basically problem solving of some sort. So thinking about these levels of interaction. Because you're looking at sort of these interactive graphics of some sort, we want to also try to do something called optimization of, it's called optimization of cognition. Basically, we want to make sure that we minimize the amount of, they call it cognitive load. So basically this idea that you want to minimize things like memorization and minimize things like taking objects that are on the screen and rotating them and things of that nature mentally. versus allowing them to actually freely do this on a given plane. This specifically tied to, it's called epistemic actions. It's this idea that we want to reduce the amount of memory involved with these mental computations and things of that nature. We want to minimize the space complexity as well, minimize things that sort of lead to specifically like human error. I have on here, I'm not going to go, obviously it's like a 30-minute video, but Tetris is sort of a good example of this. The game is sort of set up in a way so that, you know, the really good players don't have to sort of flip through the pieces. They use the information, you know, for the next one. Intuitively, they know specifically how to sort of manipulate these objects mentally so they can do the rotations. They know the optimal patterns in this regard. If Tetris was set up to be more user-friendly, if you would, it would allow you to sort of say, it would have these grid patterns given to you so you know specifically where things were going to lie. Maybe it would have a sort of a blocked off section of the given graph, if you will, to sort of maximize your scores, because it's sort of better to have multiple lines versus just one single line. And it would give you all the rotations of the next objects coming on the screen. So it's set up in a way, obviously, to be more of a game. But for the most part, if you wanted to fix Tetris, if you will, there would be sort of ways to sort of play into that to, again, sort of take some of the cognitive load or cognitive work that somebody has to do for the given display. Next thing to consider as well is this idea of change blindness. Change blindness is this idea that if we were, so a game I used to play when I was a child, you'd have sort of one given image, and then in the other image, there would be a slight difference between the other image. Change blindness goes into this idea that if we include this blank slide, if you will, between these given two images, it actually sort of affects the way we sort of see and remember these two images. So it becomes actually a more difficult task. For the most part, if we just have these two images on the same screen, for the most part, we can kind of see pretty quickly, you know, what the differences are between the various screens. But once we introduce this little blank slide, we have a little bit more of an issue in that regards. On the next screen, basically, you're going to have two images that are going to kind of flash on the screen, and for the most part, and there's going to be one difference between those two given images. And just, again, sort of adding that blank slide between them sort of affects the way. So we miss the small change, the major changes between those two images because of this blank slide. So I'll just get to this one. I'll let this go for a couple seconds. And again, there's two images that are being being shown here, but because of that gray slide between them, it becomes a little bit difficult to see the differences between those given slides. So actually right here, the turbine over here. And for the most part, this is something called change blindness. It's a sort of effect that if we have two images we're trying to show, so think about this in terms of an animation, we want to make sure that we smoothly transition between those two states. If we sort of have that blank slide or have it sort of go from one state to another, it might sort of cause issues in terms of us sort of seeing the differences between those given two scenes, if you will. And the last thing I have here is something called an awareness test. Basically, it goes into this idea of selective attention. And so I'm going to start this now. I have the sound off, but you can access the YouTube video if you're interested. The idea is that this is sort of, like I said, it's called an awareness test. But the idea is that you're supposed to count how many passes does a team in white make. Okay, so I'll let this play for a second. And so the total is 13. And the sort of trick to this, if you will, is the fact that while you're specifically, you're given a task, and that was specifically to count how many passes go between the team in white. The trick to this is the fact that during this whole, passing back and forth idea, they talk about, did you notice the moon walking bear? and I'll highlight that while it's going through. But what you're going to see in the middle of the screen here is there's a person in a bear costume sort of moonwalking behind the scene. And the idea basically being that this idea of if we're kind of told a specific task or specific action that we're supposed to be doing, it's going to be sort of tied to us so much that we are going to miss things that sort of happening in the background. This has a lot to do with sort of a magician will do this a lot of times. They'll say, you know, kind of look over here for a second, and then they'll do the magic sort of somewhere else in that regard. So when we think about sort of specifically tying this to visualization, especially like interactive visualizations, if there's a specific task that we're trying to accomplish or have the user sort of accomplish, making sure that we sort of maximize sort of that awareness. We let them know specifically to kind of look in this area. Don't hide things behind sort of in the background, if you will. And so my final little lesson for this is sort of maximizing or minimizing the amount of cognitive workload that's sort of involved by the user. You want to offload things like the memorization, rotation, changes in scene and focus as well. If you have changes in a scene specifically, you want to sort of smoothly transition between those different scenes so people sort of see the differences specifically. And highlight areas that focus attention to the user so they know specifically this is sort of tied to that given display or the specific type of task, if you will, as well. And then I believe, yes, that's all I have for today. Again, I'm kind of keeping an eye on the chat in terms of this. I haven't seen anything popped up, but I'd like to make sure I spend a few more moments here just to make sure that if there's any follow-up questions. One, feel free to always email me. I'd be happy to sort of have another conversation about like what's going, you know, some of the specific topics that we've talked about. But I'm going to make sure I kind of leave a few moments as well for anyone to ask questions as well in the chat as well. So I'm just going to kind of hang out here for a couple more minutes. And if there's any questions, please let me know. If not, that's all I have for today in terms of this workshop. Again, feel free to email me if you have any follow-up questions. But I thank everybody for your time coming out today, and feel free to share the presentation or, again, sort of follow up if you have any additional questions. So thank you very much, everyone, for attending today. And I'll talk to everyone hopefully at the next workshop.